NVIDIA just open sourced something that nobody in the AI agent space saw coming. And honestly, the developer world is still trying to process what this actually means. We're talking about OpenShell, a secure runtime that lets autonomous AI agents run freely without blowing up your company's data, your credentials, or your entire network. It was announced live on stage at GTC 2026. It launched open source under the Apache 2.0 license on the same day, and it works with Claude Code, OpenAI's Codex, and Cursor right out of the box without changing a single line of code. And the crazy part is that Jensen once said every company in the world needs an open close strategy today, the same way they needed a Linux strategy, an HTML strategy, and a Kubernetes strategy. That is how big NVIDIA thinks this moment is. So let's talk about it. Here is the thing. For the last year or so, everyone has been building AI agents. Agents that write code, search the web, manage files, run tasks overnight without anyone watching. And the productivity gains are real. But nobody builds the safety layer underneath them. You have got agents that hold live credentials. They write their own code, they spawn smaller sub-agents, and they keep running for 6 or more hours with full access to your internal systems after you close your laptop. There was no rules, no was, nothing stopping a bad prompt from leaking your API keys or an agent from writing and running code that it was never supposed to touch. That missing piece is exactly what OpenShell fixes. And the timing makes total sense because OpenClaw, the open source agent platform that OpenShell is now built to wrap, just became the fastest growing open source project in history according to Jensen Huang's own keynote. The agents are everywhere. The secure layer was missing until now. Now, here is where it gets interesting. OpenShell does not just add a warning message when an agent does something risky. It builds the rules outside the agent entirely, which means the agent cannot talk its way around them or override them even if it gets hacked. NVIDIA calls this out-of-process policy enforcement, and it is the core idea behind the whole system. The best way to understand this is to think about how your web browser works. Each browser tab is locked away from every other tab, right? If one tab crashes or gets infected, it cannot touch the others. OpenShell applies that exact same idea to AI agents. Every agent system runs in its own locked container, and the rules about what that agent can do are enforced by the runtime sitting outside, not by the agent itself. Tools like Claude Code and Cursor already ship with their own internal girders, but those protections live inside the agent. OpenShell wraps those tools and moves the final control point entirely outside the agent's reach. Now, the whole system is built around 3 main pieces. The first is the sandbox. This is not a basic container like you would use to run any normal app. This is a sandbox built specifically for agents that grow and change over time. Because here is a problem most people do not think about. AI agents are not static. They install new tools, write new skills, and spawn sub-agents mid-task. A normal container cannot handle that safely. OpenShell Sandbox can. It lets the agent develop new skills inside the box, but every new capability goes through the same policy check before it can actually run. If an agent installs a new package, the sandbox verifies it before allowing execution. And if it creates a sub-agent, that sub-agent inherits only the specific permissions it is supposed to have, not the full set of the parent. Every allow or deny decision is logged in a complete trail, so you always know what the agent did and why. The second piece is the policy engine, and this is where the real power shows up. The policy engine checks every single action the agent tries to take, whether it is touching a file, making a network request, or running a process. At the level of exact binary, the exact decision, the exact destination, the exact method, and the exact path. To make this concrete, think about a network request. If an agent tries to call out a GitHub's API, the policy engine does not just say yes or no to GitHub. It can say yes to GET request but block post request. So the agent can read from GitHub but cannot create an issue or push code. You saw a real example of these in the OpenShell Quick Start demo, where a sandbox started with no outbound access at all. Then a YAML policy file was applied that allowed read-only GitHub access. After that, a GET request to the GitHub API went through fine. But a POST request to create an issue came back with a clean policy denied error message. That level of control applied live on a running agent without restarting anything is genuinely new. And policies are written in plain YAML file, which means you do not need to be a security engineer to write them. You just describe what you want in plain text and the engine enforces it. The third piece is the privacy router. This one matters a lot for companies dealing with sensitive data. The privacy router sits between the agent and whatever AI model it is using. By default, sensitive context stays on your local device or your own premise server, processed by local open models like NVIDIA Nemotron. The router only sends data to cloud models like Claude or GPT when the policy you set actually allows it. And critically, the routing decision is made by your policy, not by the agent. The agent does not get to decide when to call the cloud. Your rules decide. This means a company can run agents on their internal documents without the data ever leaving their building unless they specifically allow it. And because OpenShell is model agnostic by design, every agent and every model can be governed through the same system regardless of which lab built them. In fairness, OpenShell is still early. NVIDIA itself calls the current version alpha software and says to expect rough edges. Right now, it runs best as a single developer setup, which they literally call single player mode in their own documentation. The roadmap points toward full multi-tenant enterprise deployments, but that is not the current reality. Some of the production layers, specifically file system and process constraints, are logged at sandbox creation time, which means you set them upfront and cannot change them while the agent is running. The network and inference layers are hot reloadable, but the others are not, which adds some planning overhead before you spin up a system. And GPU support requires the NVIDIA Container Toolkit to be installed on the host machine along with the custom sandbox image, since the default base image does not include GPU libraries out of the box. What makes this moment worth watching closely is how the rest of the industry responds. Claude Code, Codex, and Cursor already work inside OpenShell today without any changes. That is not a coincidence. NVIDIA is positioning OpenShell as the neutral ground where any agent can run safely regardless of which lab built it. And because it is open source under Apache 2.0, any company can inspect it, modify it, and deploy it without paying NVIDIA a license fee. The real question now is whether enterprise teams actually adopt the YAML policy model at scale, or whether the alpha agents of this alpha release slow things down before the system reaches production readiness. That is where we will wrap it up. The infrastructure for trustworthy AI agents has been missing for over a year, and NVIDIA just pushed the first real answer into the open. Whether OpenShell becomes the standard security layer for autonomous agents or just stepping stone to something bigger, the next 6 or 12 months of adoption will tell the story. Drop your thoughts below, make sure you are subscribed, hit the like button, and I will see you in the next one.